Welcome to this channel, and in this video we are going to be looking at how to determine the asymptotes of a function, right? Especially this applies to rational functions. And what's an asymptote? An asymptote is simply a line, right, that occurs infinitely tries to approach but never goes very close to that line, but it never touches the line, it never crosses the line, right? So this applies mainly for rational functions. We have different types of asymptotes. We have the vertical asymptotes, we have the horizontal asymptotes, and we have the slant asymptotes. But in this video, we are going to be focusing on the vertical and the horizontal asymptotes, which is that's what is part of the syllabus for the Maths 103. We're not looking at the slant asymptotes here, right? So to determine horizontal asymptotes, right? Looking at this, this is another graph. Let's look at the graph of 1 over x. This is the graph of 1 over x. So you see that carefully it doesn't touch the curve. I saying the y coordinate is not 0. It's not touching the curve perfectly, but very close to it. Very close to it, but it's not touching it. Right? So what's happening here? How do we determine it? So if you are given a function, right? If you are given a function and I ask what's the horizontal asymptote, let's start with vertical asymptote. That means that the y value is approaching infinity. The y value approaches infinity, and all you simply need to do is to equate the denominator of the rational function to 0, right? Just like if you have this function now, you are given f of x is equal to x over x minus 1 into x minus 2. The vertical asymptotes are simply the set of values for which the denominator is what? Undefined. Because at that value actually the function is undefined, and then the curve tries to get to that value, but because it's undefined at that point it doesn't touch, but it's very close to it. So at x negative 1 equal to 0, x negative 2 equal to 0, negative 1 crosses, you have x equal to 1 or x equal to 2. And if we should visualize the graph x over x minus 1 over x minus 2 on the graph, that's the curve given, that's x divided by x minus 1 into x minus 2. That's coming up. Okay, so this is what you have. So we've determined two vertical asymptotes. The first asymptote at x equal to 1, and if I should plot out the graph of x equal to 1, this is what you have. So you can see that this curve over here tries to approach this line, but it doesn't, right? And then there's another vertical asymptote at x equal to 2, as I said, which is this. The curve tries to get to that value, including this other curve right here, tries to approach that particular line, but it never touches it. So that's what you simply do. If you are given a rational function and asked determine the vertical asymptotes, all you do, equate denominators to 0. But what if you are then asked for the horizontal? Remember that for the horizontal, x is going to approach infinity, right? Just like in the case of 1 over x, just like in the case of 1 over x. So in this case now, x is tending to positive infinity, but in terms of the vertical asymptotes, right, the vertical asymptotes, it is y that tends to infinity. So you use the limit theorem, right? You should be able to evaluate limits of the function as x tends to infinity. And it's important to note that the limit as x tends to infinity of 1 over x is equal to 0. So using the example we just gave now, right? Using the example we just gave, or let's use another, like to be clearer, f of x equal to x squared all over x squared minus 4x plus 3. And he asks, determine the horizontal asymptotes. What are you going to do? You get the limit of the function as x tends to what? Infinity. And to get the limit as x tends to infinity, you divide by the highest power. That will be x squared over x squared all over what? X squared over x squared minus 4x over x squared plus 3 over x squared. And using the fact that the limit as x tends towards infinity for 1 over x is equal to 0, x squared divided by x squared is what? Is 1. The x squared divided by x squared is what? 1. All this 4x over x squared is what? 4 over x. Right? What we're having at the denominator level is 1 minus 4 over x plus 3 over x squared. And all of this will tend towards 0. Right? Using the limit properties. So basically, you can say that the limit as x tends towards infinity of x squared over x squared negative 4x plus 3 is equal to what? 1 all over 1 plus 0 plus 0. Right? Because all others will tend to 0. And that is actually 1. Y equal to 1. That's the value. So this is now a horizontal asymptote because um, y lines actually go this way in the horizontal direction. Okay, let's take another question. So let's say we are given this question in the exam. F of x equal to x minus 4 all over x minus 5 into x minus 8. And he asks in the exam, I determine the horizontal. Vertical. Let's determine vertical first. Right, so he asks for the vertical. Simply equate the denominator to 0. Now the x minus 5 equal to 0, x minus 8 equal to 0, x is equal to 5, x is equal to what? 8. So these are the two vertical asymptotes. But when it comes to the horizontal, you have to simplify the denominator. And if you simplify the denominator, x minus 5 into x minus 8 is x into x minus 5 minus 8 into x minus 5. I'm expanding it. That will be x negative 4 over x squared negative 5x negative 8x positive 40. Right, and that's going to be x negative 4 over x squared negative 13x plus 40. Then dividing through by the highest power, what are you going to get? X over x squared minus 4 over x squared all over what? X squared over x squared negative 13x over x squared plus 40 over x squared. So x divided by x squared is going to be 1 over x, right? And then 4 over x squared. So what can you infer from this? The limit of 1 over x is what? Is 0. The limit of 4 over x squared will still be 0. Any stuff that has x underneath. And the next squared divided by x squared is 1 minus what? 13x over x squared will tend to 0 because it has x underneath, right? Because x divided by x squared leaves us with x underneath. So this is 0 and then plus 0. So 0 over 1, that means it has a horizontal asymptote at y equal to 0. So simply put, you can simply put that if you are given a function such that the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is what? Is at y equal to 0. Do you understand? And then let's say you're given this question. You're given this question over here. And the question says x over x squared plus 4. And the exam, they ask you what's the vertical asymptote. Is to equate the denominator to 0, right? But if you equate the denominator to 0, you find out that if this crosses, it becomes x squared equal to negative 4. And there are no real solutions to this. It ends up with imaginary numbers, right? Plus or minus 2i, right? And that's not real. So simply put that this particular curve has no vertical asymptotes, but let's see if it has horizontal asymptotes. So for f of x equal to x over x squared plus 4, we've said that if the degree of the numerator is less than the degree of the denominator, then it has what? It's the horizontal asymptote is at y equal to what? At y equal to 0. Do you grab? So that is it. So with this, you should be able to answer any question. And then lastly, let's take this question. If you are given y equal to x plus 2 over x minus 2x minus 1, I ask what's the vertical asymptote? Equate the denominator to 0. Minus 1 crosses 2x is equal to 1. Divide 3 by 2. That means the vertical asymptote is x equal to half. Right? And then the horizontal, divide 3 by the highest power, which is x. X over x plus 2 over x all over what? 2x over x minus 1 over x. So this crosses, and then you see that these two have x underneath, right? So their limit is going to be 0. So y will be equal to 1 plus 0 all over 2 minus 0, which is what? So it has a horizontal asymptote at y equal to half. Right? So if the power of the numerator and the denominator are the same, you compare the coefficients, right? In this case, you had x, you had 2x. So just divide the parts containing x in the numerator by the parts containing x in the denominator, and that will be the value. In this case, x over 2x, which is what? 1 over 2x. So what happens if the power of the numerator is higher? If you have f of x equal to x squared plus 4x all over x minus 1, and I ask what's the vertical asymptote? Equates to 0, right? Vertical asymptote at x equal to 1. But what's the horizontal asymptote? You divide by the highest power, right, which is x squared. So that's x squared over x squared plus 4x over x squared over x squared minus 1 over x squared. This leaves us with 1 over x. This leaves us with 1 over x, right? And then you can see that all of this tends to 0. That's 1 plus 1 plus, this is 4 over x, so this will end up with 0, this will end up with 0, and then this would end up with 0. So you can have what? 1 over 0, which is undefined. So if the power of the numerator is higher than the denominator, that means that the curve has no horizontal asymptotes because you have an undefined limit, right? So that is all you need to know. Thank you so much for watching this video. And I believe that any question that comes up on determining asymptotes, you should be able to get it correctly. Thank you so much and have a nice day.